integrate that function is integral introduction. This one's for that math class that wants to pass straight masterpieces. Styling while I'm integrating that function. Gotta use this here math task. Gotta figure out the answer. Integrate that function. Find the answer derivative. Integrate that function. Use the fundamental theorem. Integrate that function. Substitute in B and A. Integrate that function. And then use subtraction. Break it down.
Whoa! Hey guys, welcome to calculus. Let me guess. Integration with U substitution? Copy that.
Hello there. My name's Ethan Hopper,
And I'm Kyle Quinty.
and we're here to talk about calculus.
So for our introduction to calculus, we have our first problem, Ethan, which is bounds 2 and 0 of x squared with respect to x. And so how we're going to solve for this definite integral is we're going to use the first fundamental theorem of calculus, which states that over a closed interval of a function, it is equivalent to the antiderivative of bound b minus bound a. So the first thing Ethan's going to show us is the antiderivative of our function, x squared. So now we found our antiderivative by adding 1 to n and dividing by n plus 1. We can now plug in our bounds to evaluate. So we're going to use the antiderivative of bound b, our upper bound, first. And then subtract from that our evaluated for bound a, which is 0. So 2 cubed is going to be 8 divided by 3. Subtracting 0 over 3, which is going to be 0. And so our equivalent answer is going to be 8/3. And that's how you find a definite integral.
Boom diggity.
Hello, and welcome to the second problem in calculus where we'll be using U substitution. So this is the problem we'll be using, and when you have your problem, you take what's in the parentheses and you set it equal to U. So it would be U equals x squared plus 4. And then you find the derivative of U, which is 2x dx. And so then you will take this, and Kelly will show you what to do next.
So next what you want to do is you want to plug your bounds into this so that way you can find your new bounds. So what you do is you would do 3 squared plus 4, which is equal to 13. So on top you would have 13. And obviously plugging in 0 would just give you 4. So on the bottom you have 4. So your new bounds are 13 on top and 4 on the bottom. So since 2x dx is what is equal to du, all you have to rewrite is u squared, since u is what's in the parentheses, du. Next what you want to do is you want to take the antiderivative of u, and you would get u to the power of 3 over 3, and you don't want to forget your bounds, so make sure you rewrite them. Next you want to use the rule that we talked about earlier, and the top goes first, so you would have 13 to the power of 3 over 3 minus 4 to the power of 3 over 3. That would give you 2,197 over 3 minus 64 over 3, which comes out to be 711.
Now back to the video. Calculus style. Then you have the answer. Woo! Then you have the answer. Woo! Cause integration's gonna solve for you. Cause integration's gonna solve for you. Integration's gonna start for you. Find the area underneath the curve. Don't believe it, just watch. Oh! Don't believe it, just watch. 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 Hey, 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 hey!
Stop! Wait a minute. How can I go about this?
Use substitution helps reduce it.
Ethan, explain a little.
Write the equation, then enter it right, then plug into your bounce. We're gonna do this, we're gonna do it nice. Nice, clear, concise. Integrate
That function.
Find the antiderivative, integrate that function. Use the fundamental theorem, integrate that function. Then your subset being A, then integrate that function. Then use subtraction, break it down.